Hello and welcome to this short video on electron structure. This is revision day 1 for Unit 1 Btec Level 3 Applied Science. Here you can see the specification for electron structure. Don't worry too much about that, but you can use it later as a checkpoint to see if you feel you're able to accomplish all of the things in this list. So, when we started learning about orbitals, probably in year 7, you learnt about shells. Shells are where we find the electrons, and generally you are taught that there are 2 electrons in the first shell, and that is the shell closest to the nucleus. The next shell is slightly further out, and there are 8 in that, and then so on. However, in level 3, we were taught that there are sub-shells. So that means that the shells you learned at GCSE are further divided into smaller parts, and we call these subshells. The first type of subshell is an s orbital, and they are spherical. So if you imagine a ball of some description, that is the shape of an s orbital. They are not flat and two-dimensional like is often represented at GCSE. These are three-dimensional structures. The s orbital can hold 2 electrons. The next type of subshell is a p orbital. This looks like an hourglass shape or a figure of 8 or an infinity symbol, but again it is 3-dimensional. And these occur 3 different types of p subshell. So you have one in the x plane, one in the y plane, and one in the z plane, which you can see on the diagram below, and these all overlap. Each p orbital can hold 2 electrons, and because there's 3 of them, we often say P6 because we've got 2 in each and there's 3 orbitals giving us a total of 6. Following that, the next subshell is a d orbital. These look like 2 overlapping hourglasses at right angles to each other, and there are 5 of those. Again, each individual d subshell can hold 2 electrons, but because there's 5 of them in total, you can fit 10. You've not previously been asked the shape of these in an exam, so it's more important that you are familiar with the shape of an S and a P, and then if you don't recognise the shape in the exam, the chances are that's the D subshell if that was to come up. Like at GCSE, the rule for filling orbitals is that the lowest energy orbital is filled first. That means the orbital closest to the nucleus. We can't start filling at the 3rd shell or the 4th shell. We have to start at shell 1. So we're going to fill the first shell, and the only thing in the first shell is an S subshell. So we can put 2 electrons in the first shell. Following that, we move up to the 2nd shell. The 2nd shell is made of an S shell and 3 P shells. Each of those hold 2. So you've got 1 S subshell and 3 P subshells. So that means 4 subshells in total, each holding 2, which is where the 8 came from at GCSE. After that, you move to the 3rd subshell, and so on. There is one unusual part in that the 4s subshell is slightly lower in energy than the 3d subshell as shown in the diagram. This means that the 4s must fill before the 3d subshell. The diagram on the left and the bottom of your screen is sometimes helpful to help you remember what order to fill them in. So the arrows show on this that you go 1s, 2s, 2p, 3s, 3p, and then 4s before you go to your 3d. And this allows you to remember to fill in the correct way. We're going to have a look now at filling this electron in box diagram, which you're often asked to do at the Unit 1 paper. And we represent the electrons, we're going to do it for magnesium, using half arrows. So magnesium has 12 electrons. We must fill from the bottom, so the first electron is going to go into that 1s shell, shown as a half arrow pointing up. The second electron will go next to it, but due to electrons having a property called spin, they must be opposite spin. So because the first one is up, the second one points down. That subshell is now full, so we move to the next subshell. So the next 2 electrons are going to go into the 1s, and so into the 2s, and then the second electron into the 2s. That's full, so we move now into the 2p. Now, electrons are negative, so when we start filling the 2p subshells, they are all the same energy. And therefore, if the electrons are able, they will sit in those subshells in separate subshells. They will not sit next to each other. We often use the bus analogy for this. If you get onto a bus, normally you will choose to sit in an empty seat. You would not choose to sit in the seat where somebody else is already sitting. The only time you sit next to somebody on a bus is like the scenario now in the 2p subshells. All 3 already have an electron. So now as we continue filling, they need to go next to each other. But to begin with, they must sit separately. And the Unit 1 paper will often test that you remember to put these in separately. So you must not pair up unless you absolutely have to. That's now full, and if you count how many electrons we have in total, we're currently up to 10. We need to have 12, so we're going to keep filling. The next subshell available to us is the 3s subshell. So we need to put 1 electron in there, that's taken us to 11, and the final electron will go near there. Now, if you look at this, we can do a quick check and check that we are happy that we have filled the right number of electrons. Yes, we can count back up and see that we've got 12, but there's another check that we can do. Magnesium is in the S block of the periodic table. That is the first 2 groups, and therefore its electron structure should finish in an S subshell. It also is in the second group, so therefore it should have 2 electrons in its outer shell, and as you can see, that is finishing with 2 electrons in the 3s shell. Finally, magnesium is in the 3rd period, so therefore it should finish in the 3rd electron shell. So magnesium is in the S block, it's in group 2, and it is in the 3rd period, and therefore it should finish 3s2. This structure that we're seeing in front of us is called the electron in box diagram. In the exam, you may be asked to complete the electron in box. This is what it means, and it means putting the electrons into these. There will be some practice questions for you at the end of this video to have a go at filling those. You also may be asked to write the SPD notation. So in that case, instead of writing it as arrows in boxes, you just write how many would be in each subshell. For example, bromine is in group 7, period 4, and has 35 electrons, and therefore this is the electron arrangement for bromine. You need to really understand what these numbers and letters are showing you. So you were asked in lesson what 1s2 shows you. This is showing that we are in the first shell, electron shell. The S tells you the subshell within that electron shell, and the 2 tells you how many electrons you are finding there. Please pause the video and see if you can now write the SPD notation for magnesium, neon, argon, nickel, and zinc. Hopefully these are the answers that you have got. If you got them wrong, pause the video again and compare and work out where you may have made mistakes. It might be you have forgotten to fill your 4s before your 3d. It might be that you have looked up the mass number on the periodic table as opposed to the atomic proton number. Just to recap about the periodic table, we can divide it into the blocks, and this does come up frequently on the Unit 1 paper where you are asked to identify what block different elements are in. The S block is made up of group 1 and group 2, but also encompasses hydrogen and helium, so don't forget those. The D block is your transition metals, and we learn later about why transition metals are in D block. P block is predominantly your non-metals, though there are some metals in there, and that is found to the right-hand side of the periodic table. The lanthanides and actinides we don't study, but they are found in the F block. We don't actually go up to the F subshell, but they occur after you get through the transition metals. One thing that the Unit 1 paper is doing more often now is writing the electron configuration, or the SPD notation, when atoms have become ions. So you need to be aware that if it is a negative ion, that means it's gained electrons. So however many electrons it starts with, you're going to have to add on some more. If you are writing it for a positive ion, they will have lost electrons, and therefore whatever number of electrons you can find from the periodic table, you will need to remove some of those in order to do that. Please pause the video to write out the SPD notation for these ions below, and then start the video again to check your answers. Please note now, when you look at these, that with the exception of copper, which is a transition metal, all of the ions above have a full p subshell. This gives them the structure of noble gases, and we know that noble gases have a full outer shell, which accounts for the structure of these ions. They have lost or gained electrons to have a stable arrangement of electrons, which is the structure of a noble gas.